Physics Part 340. The electron charge. The principle of a method to measure the electron charge is very simple. It involves the balancing of the gravitational force on a tiny charged sphere by an electric force in the opposite direction, so that the sphere remains stationary. In Millikan's original experiment, the sphere was an oil droplet which became charged by a friction as it passed out of the jet of a spray. If you do this experiment in a school laboratory now, you will probably use a very small polystyrene sphere. Millikan's arrangement is sketched in the figure. The charged droplets are sprayed between the two parallel plates connected to a source of variable potential differences, so that the electric field between them can't be changed. The tendency is for a droplet to fall under its own weight, mg. The observer concentrates on one droplet and adjusts the electric field until the weight is exactly balanced by the electric force QE in the opposite direction, of course. This gives the equilibrium. This equilibrium condition of QE is equal to QV over D is equal to mg. Millikan found that the charge Q was always an integral multiple of the fundamental quantity of charge E equal to 1.6 into 10 power raised to minus 19 C. This fundamental charge was ascribed to the charge of electrons. The experimental result that the charge on the droplet seems to be only in integral multiples of E means that the charge is quantized or exists only in discrete amounts. We've got an example for you. A negatively charged polystyrene sphere of mass 3.3 into 10 power raised to minus 15 kilogram is held at rest between two parallel plates separated by 5.0 mm when the potential difference between them is 170 volt. How many excess electrons are on the sphere? Apply the equation for the equilibrium condition QV over D is equal to mg. This gives Q is equal to 3.3 into 10 power raised to 3. Q is equal to 3.3 into 10 power raised to minus 15 into 9.8 into 5.0 into 10 power raised to minus 3 over 170 is equal to 9.5 into 10 power raised to minus 19 C. Taking the electron charge E as 1.6 into 10 power raised to minus 19 C, Q corresponds to 5.9 excess electrons. Because you can't have 0.9 of an electron, the answer must be 6 excess electrons. The discrepancy must be due to the experimental inaccuracy or to rounding errors when we have been working to only two significant figures. Now it's your turn. The charged sphere in the example above certainly loses one of its excess electrons. The potential difference between the plates remains the same. Describe the initial motion of the sphere. The electron mass. How do you find the mass of